So now the deep dive is over, I thought I would go into a more casual discussion on this episode's main topic, which was raised beaches. So if you were watching the video version of this podcast, the example of a beach I gave had this line of gray rocks on the beach, and that picture of the beach was taken in Okinawa. And what those rocks are pumice stones. So pumice is a rock that forms when a volcano erupts underwater. And that pumice is from an undersea eruption that happened in 2021. And the pumice, which can float because it's full of air pockets, reached the Ryukyu island chain, which is in the southernmost part of Japan. And it did impact the economic activities, like it can damage boats and it can damage habitats for the fisheries, as an example. And if you go, like, I took this picture in Okinawa, but I went to Kikaijima, and it also had a lot of pumice on the shorelines. And of course, in the deep dive, I said, Maria Graham said, "Oh, I have never seen a rock float." And some of the pedantic people would say, "Well, pumice can float." Of course, if that was your reaction, I'd say, don't be so pedantic. Like, nobody likes that. And she wasn't talking about pumice. She was talking about big, heavy rocks that were made of granite. And anyway, the story of Maria Graham is very interesting, and I really suggest reading the paper by Thompson that I linked that discusses this conflict she had with George Greenough. But Graham's journey to Chile was actually marked with tragedy because she was going with her husband there. And during the voyage, her husband passed away. So she reached Chile, and she was quite devastated by the death of her husband. And they said, "Oh, we can take you back to Britain right away if you want." And she decided, "No, I'll stay here for a while." And Maria Graham, I said she is a scientist, a journalist, and an academic. And in Graham's response to Greenough, she said, "Oh, I'm not really a geologist." And Thompson said she was just being modest. And if you read her account in Chile, like in Chile, her account is like 500 pages typeset. She took a lot of notes. And during that time, Chile was undergoing a civil war, and in many ways, I think it would be more accurate to call her a journalist. But of course, the best journalists are like scientists in the way that they operate, and it's very clear that Maria Graham had a lot of training to be a good journalist and a scientist. And, I can see why she was very upset by George Greenough saying that she would have been scared of the earthquake, because during that time there was a civil war going on in Chile. Like, she clearly could handle everything that went her way. And yeah, she understood the importance of the careful documentation of what was going on, not just from this earthquake, but also from the civil war that was going on. And anyway, she spent about 9 months in Chile, and afterwards she went back to England because she was invited to become the tutor for the princess of Brazil. So at that time, Brazil was a monarchy. And when she went back, her account of the earthquake was very interesting to the geologists at that time, and that's why they invited her to publish her report. And, when it comes to the word scientist, it's also important to understand that at that time, the word scientist did not even exist, and it wasn't coined until the 1830s. So, it would be more natural to describe people working at that time as academics, because they were kind of expected to be sort of knowledgeable about a wide range of different topics. And of course, at the time, there was a lot of gender discrimination, and women were not truly able to participate in the same way that men were. And, of course, the Geological Society did not even allow women to be members, but it was very clear that there were women working in fields like geology at that time. Next, one of the figures I used in the main topic was on the uplift of the land after the ice melted away to produce raised beaches. And this is based on a figure in a paper by Farrell and Clark. And this is an important paper because it sort of defined what is known as the sea level equation, sort of the connection between the size of ice sheets and the deformation of land and what sea level is. And this paper is kind of impenetrable to most people because it has a lot of equations in it. But the figure is great, and it really does demonstrate what the impacts of the ice melting has on sea level. But of course, this paper was written in the 70s, and the figure itself is very grainy, and it was from a scan from this old paper. So I redrew it myself, and yeah, it was a very important paper, though. A lot of the work that I mentioned during the topic was by Alessio Rovera, and we first met in 2018, I believe, and I was working at the Alfred Wegener Institute in Germany, and he was a professor at University of Bremen. And if you don't know the geography of Germany, it was only a 30-minute train ride away, so it was very easy to introduce myself, and we came up with a project to work on paleo sea level and ice sheet reconstructions. And Alessio has been a big influence in the paleo sea level community in the past 15 years or so, and he's done a lot of work on. He did a lot of work on this Pliocene raised beach in the eastern United States, and also we went to Argentina, and he spearheaded this large database of last interglacial shorelines called the WALLACE, the World Atlas of Last Interglacial Shorelines. And I contributed to 2 papers for this database, including the Argentina one. And I was very happy to have had the opportunity to go with him to Argentina, and I learned so much, and I really appreciate all that Alessio has taught me about the geological end of raised beaches and other shoreline features that indicate past sea level. And of course, last interglacial, I'm sure I'll have a deep dive on that at some point. And the last interglacial was a period where globally temperatures were higher than present, or well, maybe not present, but before the rise in carbon dioxide, 100 years ago. And sea level was definitely higher than it is now. But it is complicated because, as I said, the sea level changes in time and space. So in order to determine what the past sea level was on a global average, you need to consider the configuration of the ice sheets and how they melted and how they regrew afterwards. And this kind of, we don't have a lot of evidence of what this past sea level was between about 120 and 20,000 years ago. So it's difficult to know the precise history of what the ice sheets were doing in order to make a nice model of what the ice sheets looked like during the last interglacial. And yeah, I do hope to tackle this problem in the future if I get the opportunity. We'll see how it goes. I gave an example of raised beaches in the Hudson Bay area, and this picture was from the work of Isabelle McMartin. And Isabelle has been a very prominent glacial geologist who's done a large volume of work on the glacial history in the area west of Hudson Bay. And I have a great deal of respect for her work on this topic. And it can't be easy to do work in this very remote area. It's one of the most remote areas in North America. There's only a couple of villages up there. So to do the field work, you need to have a lot of, there's a lot of logistical difficulties. And finally, I wanted to say my trip to Argentina was quite a whirlwind. So when I did the trip, I started in Japan, actually. I'm currently in Japan. I had tickets to the Rugby World Cup, which happened in October 2019. So, but I had to be in Argentina at the end of October 2019. So I flew from Japan to Germany, and then from Germany to Argentina. And that's almost literally the opposite end of the world from Japan. And yeah, it really, I really hope I don't have to do a trip like that again. But it was definitely worth it. And Patagonia is really a desert area. So all that's there is some shrubs and grasses and sheep, lots of sheep. And the native animals, there are these guanacos, and they kind of look like a llama. They're a bit different, but kind of look like that. And there are these little birds called rhea. They're kind of similar to a mini emu. They're ratite, and so those animals were everywhere. One very notable thing in Patagonia is that everything is covered in these little rocks. They're, maybe 1 to 2 centimeters wide, and the rocks are everywhere. And you're like, there are no hills, there are no outcrops of rock. Where did these rocks come from? And Charles Darwin, in his 1846 papers on Patagonia, he also was like, why are these rocks everywhere? And he called it the Great Patagonian Shingle. And yeah, even now it's not really clear where these rocks come from and why they are there. The leading hypothesis is that due to the rise of the Andes and the general global cooling in the past 5 million years, an ice sheet formed over the southern Andes called the Patagonian ice sheet. And basically the ice sheet grew, and that eroded the rocks off of the Andes Mountains. And due to the meltwater flowing off of the ice sheet, that distributed these little rocks everywhere. And the rocks have been sort of polished off because of wind action Yeah, it is incredibly windy in Patagonia. There were dust storms when we were there. Before I finish off on this topic, I should mention that the trip to Argentina that I made was part of a European Research Council funded project called Warm Coast. And Warm Coast was led by Alessio Rovera, and the goal of this was to investigate last interglacial sea level around the world. And the World Atlas of Last Interglacial Shorelines was also part of that. So that's it for Ray's Beaches. I hope you enjoyed it.